This is homework set 37, questions 16 through 20. Question 16, let's solve this. So I've got an addition. I'm going to combine these together. I'm going to compact it and write it as a single logarithm. How about the logarithm base 2 of the first times the second equaling 2. Now, the logarithm is the exponent. That 2 will be an exponent on that 2, the base. So 2 to the 2 is equal to x squared plus 3x. 4 is equal to x squared plus 3x. Let's set it equal to 0. So we'll get 0 is equal to x squared plus 3x minus 4. Factor. 0 equals about x and x. I'm going to try plus 4 minus 1. That'll give me a plus 3. So from here, I can get x equals negative 4, right from there. And from this one, I can get a 1. Now, remember, these are potential. We have to check that what we get here is the log of a positive number. Now, I'm just going to run quick checks. What if you put in negative 4? All right, put in negative 4, all the way back to the beginning. If you put negative 4 in here, you're getting the log of a negative. All right, so log of a negative, so negative 4 cannot work. And over here, negative 4 plus 3 is a negative 1. For sure, negative 4 doesn't work, so we can cross that one out. Now, what if you put in the 1? If you put in the 1, I get the log of 1. That's positive. The log of 4 is positive. All right, so both these work. Well, both of these work for 1. All right, so here's what I'm saying. So first up, I have to prove it to you. If x equals negative 4, I mean, I don't want to just talk my way through it. I have to show it. If I put in negative 4, I'm going to get the log of a negative plus the log of a negative, and I know can do that. All right, so negative 4, x equals negative 4, x cannot be negative 4. Now, if I put in 1, I will get the log of a positive, log of a positive plus log of a positive, and this is, all right, this is okay. We can do that, right? We can do that. All right, so what I'm going to say then is my solution, I thought I had 2, but I really have only 1, and it's x equals 1. Question 17 tells us that doctors use the Henderson-Hasselbalch formula to calculate the pH of a person's blood. pH is measure of acidity or alkalinity of a solution. The formula is this one right here. The pH is 6.1 plus the log base 10 of x over y, where x is the base concentration and y is the acid concentration. Now, if most people have a blood pH of 7.4, use the formula to find the ratio for an average person, round to 2 decimal places. So we are given this formula here. And we're also told that normal people will have a blood of 7.4. So let's put that in here. 7.4, that's going to be the pH, and that is equal to 6.1 plus the log base 10 of x over y. Now, let's subtract here. All right, so 7.4 minus 6.1 is equal to the log base 10 of x over y. Now, 7.4 minus 6.1 is 1.3. That's equal to the log base 10 of x over y. Now, the logarithm is the exponent. The logarithm is the exponent, right? So the exponent, 1.3, goes on that base of 10. So we will have 10 to the 1.3 is equal to x over y. Now, on my calculator, I found that 10 to the 1.3 comes out to this, 19.9526 bunch, but we're supposed to round this to 2 decimal places. So over here, the 2 is below 5, so I'm just going to round this to 19.5, so I get this. 19.95, that is equal to that x over y. Now, here's what we're asked. We're just asked to find, use the formula to find the ratio. We're just trying to find x over y, so we're done. Right? We're not trying to find x and y individually, just the ratio. Question 18, total calculator problem. And notice the base here. There is no base, so the base is assumed to be a 10. So on your calculator, you are going to find a key. It's in the very left column, kind of in the middle. There's a key that says LOG on it. Right, we're going to use that key. So for part A, you're going to press that log key, right? You're going to press LOG. And when you do that, when you press the log key, you get a parentheses, all right? So here's what you get. You get LOG, parentheses. Now put in 888 and close the parentheses. Now they're telling us to round to at least 2 decimal places. So when I get this, I'm going to get this. I get 2.948. So how about if I round to 2 decimal places? 2.95, right? So this is 2.95. Now part B, press that log key again, and we will get log, parentheses. Now put in 88.8. All right, so when I put in log of 88.8, I'm doing it now, I got 1.95, okay? So I get 1.95. Now, for part C, let's put in, all right, this is part C. I'll just write, put in log of, what do we have here? 8880. All right, so I'm going to press the log key, 8880, press the right parentheses, and now I get 3.95. Part D, now we want the log of point, put that 0 out in front, 0888. All right, so actually, can you guess what this one's going to be? That might be a little harder to guess, but I'm getting this. I'm getting this to be negative 1.05. Okay, so let me fill these in. Negative 1.05. This one up here was 3.95. And now finally, let's do that last one. Let's take the log of 888 and 2 zeros. All right, so 888 and 2 zeros. All right, log 888, 2 zeros, close. How about 4.95? Okay, 4.95. Now I see a pattern here. Do you see it? We started off with 3 eighths and you got 2.95. Now, drop down an 8, right? Take the decimal and move it to the left 1. If you move to the left 1, you're 1 less, right? 295, you move the decimal place to the left, it goes down by 1. Now, move it to the right. Start up here, move it to the right. If you move it to the right, well, the 295 goes to 395. It goes up 1. Now, move the decimal over here. So what do? It's like I'm moving it 1, 2, 3, 4 places. So it's going to go down by how much? 1, 2, to 1, to 0, to negative 1. So it went down by 3 places. And then if I add 2 zeros on the right, I'm going to go up 2, right? Up 2. 295 to 495. Question 19 asks us to use the change of base formula to evaluate this expression right here. What is the log base 4 of 25? Well, 4 to what power is 25? That's a hard one. I don't really know. So let's change the base to something that we know, something more convenient like base 10, because that one is on the calculator. So how about if we write the change of base formula? That says this: if you have the logarithm to some base a of some number b, that's what we have, right? We have our base is going to be the a, and the 25 is the b. So if you have the logarithm, some base of some number, right, you can rewrite this like this. You can pick a different base that you like. Log base, I'll call it c. Log base c. Now here's how I remember this. High number goes in the high position. Low number goes in the low position. So I'm going to write it a b here and an a here. All right. This is a change of base formula. So now we're going to have that the log base 4 of 25 is equal to, now pick a good base that you like. It's on the calculator. How about log base 10? Log base 10. And high number goes in high position. Low number goes in the low position. Now on your calculator, just type this. Log. Now press the log key on the left side. Press the log key. Right, it looks like this. There's no base, so it's a base 10. Automatic base 10. Put in 25, close the parentheses. Divide. Put in log, parentheses you get automatically. Put in a 4 and close. Now I'm showing this. I'm showing 2.3219 ... keeps going. And it says to approximate it to 4 decimal places. So after that 9, I'm getting a 2. So at a 4 decimal places, 1, 2, 3, 4, that number right there is below 5, so I'm going to drop it. So 2.3219. And then what it says this. It says that, okay, up here at the top, the log base 4 of 25 is what number? So we're saying this, that the log base 4 of 25 is equal to, well, I'm going to say about equal to 2.3219, which means, right, logarithm is the exponent. So if I raised 4 to the 2.3219, I'm going to get very close to 25. Question 20, our last problem here says to simplify this logarithmic expression as much as possible. So I'm going to compact it into one logarithm. Notice I've got a minus sign. So I'm going to write log base b. Now, minus sign, fraction bar. I got multipliers out here. Those multipliers become the exponents. So positive goes on the top, and the minus one, the minus goes on the bottom. So this is going to be over y squared. So that's what we're looking for right there. And that's all the questions in homework set 37.